Well, hello everyone. Welcome to Unit 5 in Macroeconomics. Tonight we'll be talking about unemployment and cost of living. But first, let's go ahead and review last week's Unit 4. And what we covered last week, we talked about how to compute gross domestic product. And we were looking at the fact that it is the dollar value of all of the final goods. Now it says final goods, that means if you have a good that is made that is going to be part of something else, then it does not get counted separately, because if it did, it would be double counted when you computed the cost or the price of the final product. So we only count final products, we don't count the intermediate products. We also include all the services that are performed within our country. Again, we're measuring for the whole country, and we are measuring for a specific period of time, be it a year, be it a quarter, which is 3 months, or be it monthly. Okay? Things that are not included in gross domestic product are things that we would grow ourselves at home, work that we would do at home for ourselves, such as mowing the grass, when you could go out and hire somebody to do that. If you hired somebody, then it would be counted. If you do it for yourself, it's not counted. And then the other thing is any illegal transactions, such as somebody, illegally buying drugs on a black market somewhere. Okay. The other thing that we'll notice is that there's been a significant change in the gross domestic product, and that gross domestic product actually represents our standard of living. So you will notice that 100 years ago, back in the early 1900s, that the standard of living was significantly different than it is today. And if you look at the chart of gross domestic product down in the lower left, you will see that it too has a was significantly lower 100 years ago than it is today. So the overall gross domestic product does represent the average standard of living, and my cell phone is dinging like crazy, probably because somebody's putting things into the schedule, such as my wife. Anyhow, that said, so we see the change there. The other thing that's interesting is how we compute that gross domestic product. It is made up of consumer spending. That's the first and normally a very large portion of it. We'll also have investment spending, investment both in terms of business and in terms of households. Now, normally the investment that a household makes is when they buy a new house. Okay. The rest of the investment is in terms of what businesses do when they buy equipment, change their inventory, or build a new building or whatever. Then we have the government expenditures, which is the labor, in other words, what they're paying to all the government workers, and then any government expenditures on public works or what have you. And then finally, we have to take what we export to other countries, but we also have to subtract out anything that we import from other countries to come up with that total gross domestic product for the country. Now, we are concerned too with the difference between what nominal gross domestic product is and what the real gross domestic product is. Now, what would make these different? Well, normally it is what we call inflation. So nominal is whatever the dollar amount is today or in a given year. That was the stated amount. But if we want to adjust for inflation, and all inflation is a rise in price without a commensurate rise in value of the product. So you see the lady down in the lower right here, and again, if she went out and bought groceries back about 50 years ago, back in, say 1962, 1967, somewhere around there, it would have cost her about $30 for a week's worth of groceries for a family of 4. Today, that same groceries for a family of 4 is going to be much more than $200 a week. So the question is, did the butter get any markedly better enough to justify its price increase? Is the milk any different? Is the dozen of eggs any different than it was 50 years ago? Not really. But its price is significantly different. So, its price has changed, but the intrinsic value of the product has not changed. That is inflation. Okay, of course we can measure that. Another thing that's interesting that gross domestic product numbers will tell us, it will tell us differences in countries. So you can see here from the arrow that the United States has a very high gross domestic product per person, and we'll talk more about that tonight. These numbers are for 2007, and they're comparing the standard of living in Bangladesh, which has a significantly less, matter of fact, less than 1/40th of what our gross domestic product was in 2007. So significantly worse. And of course, their standard of living is significantly different too. So those are some things that we can tell, that we can use gross domestic product for. If you have any questions, please be sure to get a hold of me as soon as you can, and I'll be happy to answer them. So what we're going to do tonight, we're going to continue looking at the nation, if you will, but we're going to kind of zero in on unemployment and cost of living and some other things related to that. So, to begin with, we're going back to our gross domestic product, and we're looking at the numbers over the last 50 years, going back to 1967 to roughly a year ago, give or take a little. And you'll see that we are measuring gross domestic product in billions with a B of current dollars. So again, this particular chart will show us current numbers. Some things that we can tell about this, if we look back in 1967 and we see we're 850 billion with a B dollars, okay? Springboarding ahead to 2016, which is the more recent numbers that I'm using for these graphs, now we have over 1,800 billion. And so let's kind of get rid of the zeros and make a little bit more sense, okay? And to do that, we just strike out the zeros, and now we see that we're actually comparing 850 billion with 18,624 billion dollars. So $18,624 billion. So a significant change. As a matter of fact, that change is 21, almost 22 times what the original 50 years ago dollar value was. So that's a significant increase. We have increased 22 times the original amount. Okay. Now, what happened to our population back then? Well, if we look at the population back in 1967, we were just under 200 million people, 198 million people. Okay. Today, we're hovering around 325, 326 million, actually a shade higher today in 2018, but in 2016 it was 326 million. So our population has increased over that 50 years, okay? And it's increased by 60%, but nowhere near the 2,190% that the gross domestic product has gone up. So that said, we need to be able to compute some numbers, and you will have the opportunity to compute these numbers in your Unit 5 assignment. Of course, you'll be using different sets of numbers, but you'll be doing this kind of calculation. So you see, we have the nominal gross domestic product, GDP, in 1967, and we have the population in 1967. And then in 2016, roughly 50 years later, we have the nominal gross domestic product and the population again. So, that said, if we divide the population each year into the gross domestic product, and we see in 1967 the average gross domestic product of the country per person would have been a little over $4,000 a year. So about $4,278 per year. What would it be in current time? Well, taking the gross domestic product and dividing it by the population, we now get $57,000 of gross domestic product per person. Interesting numbers, huh? Okay, so what has happened during this time? We saw the gross domestic product increased by 2,190%. Population went up by 60%. But the gross domestic product per person, now this doesn't mean that everybody in the country has that share of income. But what it means is if we take the total amount of gross domestic product throughout the whole country and we divide it by all the people, that would be each person's share. Okay? And we see that it has gone up by 1,335%. So an interesting number again. Okay? Let's look at this idea of inflation once again with some made-up numbers, but I think it'll illustrate what we're looking at. Let's say that we had total sales in a particular period of time, and we'll use gasoline as an example, and let's say the total sales that we were measuring was $60,000 on the left. And then we go to a new period of time, and we see if we add up the total dollars of gasoline sales, we see our now total dollar value is $132,000. And looking at that, we'd say, wow, we have increased our sales by 120%. Aren't we doing marvelously? Okay? And that would sound really interesting. And the question really is, what is our real growth? Well, if we look at the number of gallons of gasoline that we changed, we actually went from 30,000 gallons at the beginning period, where the price was $2 a gallon, to 33,000 gallons in a more recent period of time, but now the price is $4 a gallon. So we see we've actually only increased our production or our consumption of gasoline by 10%. We actually increased it by 10%. Sorry, I skipped that call. And but we doubled our price. So doubling of the price is what made that total sales figure look so dramatic. But really, we only increased our consumption by 10%. Okay? So that's kind of an idea of what's happening with inflation. Okay? So, if we look at things, how do we measure the health of our economy? And that's something today that should be of concern to all of us. Okay? Well, obviously, we can look at the gross domestic product. We know what that is. We would need to look at productivity too. How much output are we getting per worker? So that's that gross domestic product per person. But then we've got to take out that inflation, the rise in prices without a commensurate increase in the value of the item. So let's go back and look at what this gross domestic product per person has been doing over this period of time. And so what we're going to do is we're going to try to take out some of that inflation so that we're looking at real numbers. So, in other words, real growth numbers. So if we're going to call that real gross domestic product, and we want to measure it per person, so it's per capita, capita being the Latin word for person, and for individual person, I should say. And then you notice on the left side there near the top, in parentheses, it says in $2,000. What that is, we take the buying power, and we say what the gross domestic product is in the year 2000. And then we back down each year to see what the equivalent buying power would be in those kind of dollars. So we adjust everything to a constant dollar amount to get rid of that inflation. And then once we have our gross domestic product adjusted that way, we divide by the population. So we still see an upward trend, and we see a big bounce in the mid-1940s. If you look at that hump in the graph there, what we're really looking at is all the extra production that the United States did for World War II. Okay. If you look to the left of that big hump, you see a dip just after 1930, and that dip that actually started in 1929 was what they called the Great Depression. Okay. Now, if you scan along a little further, you're going to see in the late 60s, there's another sharp little dip where we had a serious recession. And then there's another little dip in the late, late mid-1980s. And that mid-1980s was, a little techno bump, if you will, a little recession. And then there's another recession in the late 80s and early 90s, which was the dot-com bubble. And so we see how this real gross domestic product can be measured per person, again, over this period of time, and we see how it tracks the ups and downs. And again, what we're trying to say is, what is the standard of living of our people? Okay, and we're measuring it by average or per, gross domestic product per person, per capita. Okay, hope that makes a little sense. We're going to talk a little bit more about this cost of living thing. Okay, we're going to use some examples to show how inflation has changed over time. So, I'm sure very few of you are old enough to remember 1967, actually 1962. I can remember going to the then first McDonald's in the big city where I was going to college at, and we could get a burger for 15 cents. What a deal. Well, those days are long gone, okay? But let's compare burgers for a little while, okay? Again, back in 1962, we're talking about 15 cents. About 10 years ago, the little McDonald's burger would go for 99 cents, and that sounds like it hasn't increased all that much. It increased about 5 times, about 560%. Okay, but it's a little deceptive because they use that particular product as a loss leader to draw people in, hoping they're going to get the Big Mac with all the trimmings, right? So let's kind of take a look at this idea of what is this basket of goods, okay? And how are we going to come up with a way of adjusting that gross domestic product number, the nominal gross domestic product for a particular year, how are we going to adjust it for inflation? Well, the Department of Commerce came up with an interesting way of doing that. They came up with what they call an average basket of goods that the typical consumer would purchase. Now, this is not just groceries, although that's what the graphic here shows, but it's also a certain amount of clothing, a certain amount of transportation, a certain amount of housing. What do the average person across the country live on? And so they find out what these things are that a person needs by doing studies, and then they go back over time and they say, how much does each of these things cost in a particular year? And they can therefore adjust the change in price. They can monitor the change in price of things that have not changed their value very much. Okay, so again, going back to 1962, we see that basket of goods would have been about $30 for a week. Okay, moving forward to 2017, 2016 roughly, we see that the price jumps to $245 a week for the same family. That means that over that 50 years, the consumer price index changed by 8 times by 812%. So it had gone up by that much over that 50 years. So if we were to go back in time and look at what the dollar amount that somebody got paid then was, and we multiplied it by 812, that would tell us how much they would need today to buy the equivalent things. That's how we're going to measure inflation. So, another thing we can look at is over that same 50 years, what happened to the federal minimum wage? Well, the federal minimum wage changed in 1962 to $1.15 an hour. A whopping $1.15 an hour. Because prior to that was 75 cents an hour. Okay? And so in 1962 they made the big change to $1.15. Now, what happened then? Well, that person working for $1.15 an hour at unskilled work, at federal minimum wage, needing $30 a week to feed their family of four, they would have to work 26.2 hours of that 40-hour week to have enough money to buy the groceries. Okay? So, what's happening closer to today? Well, the federal minimum wage has gone up over those years. It's gone up to currently $7.25 an hour. That's a little over 5 times, 530% growth in the minimum wage. Okay? But what is it going to take that same worker? How many hours are they going to have to work at minimum wage now of $7.25 an hour to buy the groceries? And we find now they're going to have to work an extra 7 hours, almost 8 hours. They're going to have to work a total of 33.8 hours just to buy the groceries. How are they going to have money to pay the rent? Okay? So you see how we're measuring that change in standard of living and the change in cost of living. So, if we were to go back and look at federal minimum wage, and remember there's some argument today to making the minimum wage be $15 an hour. Okay? So we see that over the last about 60 years, looking at this graph, minimum wage has gone up consistently. However, if we adjust the minimum wage to a standard set of dollars, in this case we'll use $1996 because that happened to be the amounts that I was able to get this graph for, we see that in the 1970s the minimum wage was as high as it could get, and after that the buying power of that minimum wage consistently went down. Okay? To the point that it is much lower than it was back at the start. Okay, so now we can talk about inflation, and at the same time there is the possibility of prices going down. And if you look at the graph here at the bottom, which is graphing the consumer price index, which is that basket of goods, okay? So what we're doing is we're measuring changes in the price of that average basket of goods, not just the groceries, but and I put in quotation marks, the basket of goods that the average person needs to purchase. And what we find is, again, we see that very sharp, deflation, which means prices are going down back in the 1929, 1930s, which was the Great Depression. And then we have cycles where the prices of things go up, the consumer price index increases, and then there are periods of time where it goes back down again, and then spikes and then back down. It is interesting if you look at the mid-1970s to the mid-1980s, we had a prolonged period of high inflation. Now again, many of you may not be old enough to remember this, but there were periods of time in the mid-70s, 77-ish, where the interest rate on a credit card was 25%. Think of that for a minute. Okay, we have high interest rates now on credit cards, but imagine an interest rate of 25%. Yeah, that's significant. So that means if you borrow $100 on your credit card and you don't pay it off in a period of time, the average rate for the year, you're going to pay the 100 back plus another 25. Okay, so a very significant amount. But then in the late 1990s, up through 2000, we had a fairly decent period of stability. As a matter of fact, it actually ended going up through about 2006, if I recall correctly, 2007, early in there. Then we started into the housing bubble. And the housing bubble burst in 2008. But this particular graph doesn't go that far. Now, how we stabilize the numbers to take out inflation, we used the year 1983 as the base. That was, whatever that was 100%. And then we plotted the change from 1983 using whatever the numbers were for that particular year. Okay. Okay, moving on a little further. Again, we're looking at a very similar graph to what we had earlier. This is the gross domestic product, but this time it is in billions of dollars, because what we're trying to look at how our output has changed over the years. And this goes back a little further, basically 1948 to relatively current, about 14, 15 years ago. And again, we see that upward trend. We see a few minor dips, but when we adjust for inflation, we see that we are increasing our output of the whole country over that entire period of time, with a few little blips, but not very big. Okay, moving on a little further. What happens when we convert that to per person? Again, we looked at this very similar graph a little bit earlier. I stretched it out going back all the way to 1900, so it covers a little over 100 years. But I wanted you to see, and we've adjusted it to a slightly different period of time, to $2,000, to the year 2000. But it gives you an idea, again, of what the change is. There's some ups and downs that we talked about earlier, but the overall trend is increasing during that period of time. Okay. Now, let's take another look at some computations that we need to make. So this time we're going to compare two different products. We're going to be looking at, and we're going to say these are the only two products that this particular country makes. Okay. And so what we want to do is see how things are changing. And we're only going to look at over a 6-month period of time. And specifically, we're looking at the January cost and then the July cost. And again, these are just made up numbers, but they give you an idea. So let's say we used 50 gallons of gas per month during this time, and the average cost in January was $2.05. The average cost in July was $2.59. Now, at the same time, some of us with iPhones are using cloud storage, iCloud, and if you wanted 200 gigabytes of storage, and you were going to use 2 of those, or 400 gigabytes in a month on average, and let's say this is the total amount that is produced by this country. And we see the original cost is $2.75, and then in July it's $2.99. So what we want to do is see what kind of changes, what's the percentage change in price. That's what we're looking for. So it's easy enough to take the July price, subtract the January price to see what the change is. If it's a plus number, it's an increase. If it's a minus number, it is a decrease. So we're going to take the July price and subtract the January price. And then we're going to divide that answer by the January price. And then we're going to multiply that by 100 to get a percent. Okay? And so when we do the computation for gasoline, we see that the gasoline, we take the $2.59, the July price, subtract the January price, $2.05, divide that answer by the January price of $2.05. We're going to get a relatively small number. We're going to multiply that number by 100, and that's going to give us 26.34% as the increase in price of the gasoline. And again, you're going to do computations very similar to this for two products. Okay? Then, what about for the iCloud or the cloud storage for 200 gigabytes, and we use two of them? Once again, we're just looking at the price, and we do the same computation, taking the July price, subtracting the January price, dividing that answer by the January price, and then multiplying the answer by 100, and we get an 8.73% change in the price of cloud storage. Well, that's part of what we want. The next thing we have to do is figure out, now that we have some prices and percent changes, we need to see what is going to be the change in our CPI, our Consumer Price Index. And we're assuming this is the basket of goods. Okay? Well, so the first question is, what is the market value of our basket of goods? Well, to compute that, we're going to have to take the number of units of gas per period of time, times the gas price, and we have to add that to the number of units of the cloud storage and multiply that by the cloud price. And then we add those two numbers together. Okay? So, in doing that computation, so that's going to be the first part, and then to actually get our percentage change, we're going to take that the July market basket value, subtract the January market basket value, take that answer and divide it by the January market basket value, and then multiply that by 100. So let's do that calculation. And again, you see here that we have the gas on the left part of the calculation and the cloud storage on the right part. And so we do the calculation, and we find that the January market basket value was $108, and the July market basket value was $155.48. Okay? So we go one more step, and now we have to compute that change in the Consumer Price Index of this two-product economy, very small economy. And again, we do that July market basket value minus January market basket value. And when we do this computation, we find that our change in our Consumer Price Index that we're computing for this two-product country ends up being a 43.96% increase in the Consumer Price Index. So what you're probably going to want to do, since these calculations get a little unwieldy if you're trying to remember them just off the top of your head, you're probably going to want to put these slides on half of your screen. Okay? The other half of the screen, put your problem. And go find where the calculation is and then thumb through it, and so that you can figure out how to make the calculation. And my suggestion is you make the calculations on scratch paper somewhere until you're comfortable that you got the right answer. Then create the calculations on your paper so that we can see what you did. Okay? And make it a lot easier in grading too. Okay, so here's a little interesting tidbit that tells you the same thing. If we go back to 1967, July as a matter of fact, I could even be more specific. That probably was actually in July. It was before I reported for duty at Fort Eustis for officer basic training as a second lieutenant in the Army Transportation Corps. Okay? And you'll notice that as a second lieutenant, and I was less than 2 years. It was my first year in the service. Matter of fact, my first month. The base pay was $321. Now, we had another allowance for subsistence, if you will, because officers have to pay for their own food. So it was at $47.88. And then we had a housing allowance for officers living off base. And they did not have sufficient housing on base for married officers. And so my then wife and I had an apartment off base near Fort Eustis in Newport News, Virginia. And so they gave us another $120 a month to cover housing. So back then, fresh out of college with a bachelor's degree in economics and a second lieutenant commission, I was making a grand total of $488.88 a month, and I thought I was doing really well. Now, if we added all that up for a year, you'll notice it's going to be about $5,866 and some change for the year. Okay, now we're looking at the Consumer Price Index, okay, going all the way back to 1988 by month, all the way up to 2017 September. Okay. Now, when I did these graphs, that was the most current information I could get. And what you notice in the circle, we're using 1967 as 100%. So what we're looking at is what is the percentage change from 1967 to today in the Consumer Price Index in the United States, which is driven by the market basket of goods, comparing what a person would have needed to buy in 1967 compared with what they buy today, and what is the price differential. And you will notice that if 1967 was 100, then in September of 17, that $100, in other words, to accomplish the same thing that $100 did in 1967, you would have to have $739.36. Okay, so that number is the Consumer Price Index adjustment number that we're concerned with. Okay, so if we go back to what I was doing, and again, I did a little different adjustment on this one, but we're going to use that same number, that CPI in a minute. But we're trying to figure out what would it take me to live, as a second lieutenant today. So, and again, you're going to do a similar computation in your assignment. So I want to walk you through the steps. So we take the amount and the Consumer Price Index today, and then divide it by the Consumer Price Index then. Okay? And so we know that I had a total of $488.88 coming in. We know from the previous slide that it was $739.59. So, and then we're going to divide that by 100. Okay. And so we do the multiplication. You see the number there. And what we end up finding out is, in order for me to have the equivalent buying power that I had as a second lieutenant in 1967, I would have to be bringing in $3,615.71 a month in September of last year. Okay, just barely, not even a year ago. So that meant that somebody making just under $6,000 a year, $5,800 and something in 1967, would have to make over $43,000 today in order to have the equivalent buying power. Remember, this is inflation that we're looking at. Okay. Now we want to switch gears a little bit and talk about unemployment, because that goes hand in hand with this. Okay, and if we look at employment figures over that 50 years, okay, you will notice that we start off in 1967 with about 3.4% unemployment. We'll define what that means in a few minutes. We had a peak period in November of 1982 where we actually had 10.8% unemployment. So we had a lot of people unemployed then. Okay. As we come forward, we see there's another low period in about 2000, Yeah, 1999 to 2000, somewhere in there. That meant we had most people working at that time. So the very low points on this graph show when a lot of people are working. The very high points show when a lot of people are out of jobs. Okay? Then we look at 2008. Okay? 2008, 2009, 2010, and now we have very high unemployment. And everyone said, oh, that unemployment is awful. It's almost 10%, and it was awful. But in 1983-84, we actually had worse unemployment. Okay. Now, you notice 2017, just after that, in early 2018, we see 4.2%. You might be pleased to know that effective in June, actually the end of May, unemployment figures showed in 2018 that we were at 3.8% unemployment. That means most people are working. Okay? So, what do these kind of numbers mean? Well, this graph is kind of interesting for you because what it shows you is it shows the unemployment fluctuation from 1948 forward. Again, when you see the high values on this little orange graph, that's when a lot of people are out of work. And when you see the low values, that's when a lot of people are working. Now, what's interesting are the purple bars, because those purple bars represent significant recessions in our economy. And you'll notice that as the recession starts, the left side of each one of those bars, we normally have an awful lot of people working. We have a very low spot. And as the recession is about to end, the very right side of the purple bar, we see we have the highest unemployment. And as the recession ends, we start putting people back to work. We get a lot of people working again, and then bingo, there's another recession. And then we suddenly have a jump in unemployment. And this continues through virtually every recession. Okay? Sometimes it's big, sometimes it's little. We don't actually, this graph doesn't show us the Great Recession of 2008 because this particular one ends in 2004, but it gives you the idea. The same thing would have been true in 2008. And our recovery now has gotten us down to 3.8, which is pretty doggone close to the lowest unemployment we've had in 50 years. And if you go back even further, back about 70 years, again, we're in that same range. Okay, where 3.5% is the lowest. So, what is this thing called unemployment, and how are we going to calculate it? Because, needless to say, you're going to have to do that. So, let's start off with what our current population is. And again, this is 2017. So we got about 326 million people in the United States. Okay. Of those 326 million, roughly 245 million, 0.3 are adults. Okay? Because we're not going to count children because children aren't supposed to be working, right? So that means that people under the age of 21 and not in the labor force, that means that they're either going to school or whatever, okay, but they're under the age of 21 and they're not counted. That's about 80.7 million people. Now that we look at just the adults, the question is how many of those adults are actually in the labor force? Now remember, we're going to have some people who are counted as adults. They're 21 years of age or older, may be going to college, may be working on a graduate degree, and may not be working. Some of them are going to be household folks, where maybe the wife or the husband stays home with the kids, and the other spouse works. Okay, well, that one staying home with the kids is not part of the labor force. And of course, we have senior citizens, that people that are retired and not working, and they're not part of the labor force, even though they are part of the adult group. So our census figures will give us those numbers. And we see that out of that 245 million, we have 91 million that are adults not in the labor force. And remember, we're trying to count what unemployment rate really means. So what we find is the adults who are in the labor force represent about 62% of the adult population. So if we look at just the blue bar that says adults, 245 million, and we look at the adults in the labor force, that represents about 62.7% of the adults. Okay. Moving on a little further, what we're interested in computing unemployment for is only related to labor force participation. In other words, who are the people who are actively involved in the labor force? Okay? And what we're concerned with is we're not really looking at that other group of adults who are not looking for a job, if you will. That's not their mission in life. Okay? So, then the next question becomes, of those adults in the labor force, in other words, participating in the labor force, we have 147 million at this time who are working. Okay? Now, that means immediately that we have some that are unemployed. Some of the 153.8 million adults in the labor force, if there's only 147.3 working, then there's got to be a whole bunch that are not working, right? And so we find by simple subtraction that that group represented 4.2% of the labor force. Now remember, we're just counting adults in the labor market, not people who are not even interested in working, or, they're going to school or retired or whatever they're doing. Maybe they're ill, maybe they've been injured, and they're not part of the workforce anymore. Okay? So we're only interested in measuring that little percent. Okay? And that's where that 4.2% or 3.8 that I gave you just a few minutes ago, as current as of May of 2018, that's what that number means. Now, what you're going to have to do is do some calculations about this. So we see we've got 95.8% of the workforce working at the point that we made this measurement. Now, we can take all those chunks, if you will, and see what they mean. Okay. Again, we got the people who are under age 21 and not in the labor force, and then we have the black bar, which is adults not in the labor force. And then we have the red bar, which is the number of people unemployed. And then we have the green bar, which is the working group. And all we're measuring is that red bar. Okay? So the question becomes, if you have a table with information, or you're given information in a problem similar to what you see above, in line A as in alpha, let's say you're given the adult population, you're given the number employed, and the number unemployed. And you're asked to compute the labor force, the unemployment rate, and the labor force participation rate. How do you do that? Well, again, simple calculation. We can compute labor force real easy because we have the number employed and we have the number unemployed. So if we just add those two numbers together, that is our labor force number. So we add the 147,343,370 employed, plus the 6,459,730 unemployed, and that'll give us 153,803,100 as the labor force. So you can compute that number. Okay. The next number you have to compute is the unemployment rate. Okay. How are we going to get that? We're going to take the unemployed number, which we have right up above, and the and we're going to divide that by the total of the employed and unemployed, okay, which is which is the labor force, people in the labor force. And when we make that computation, we get our 4.2% unemployment rate. And the final number we have to compute in section A is the labor force participation rate, and we're going to do that by taking the number of employed plus unemployed, and we're going to divide it by the adult population. And we can fill that number in, which is our 62.7%. Okay, let's pretend, and this will happen too, that you're given problem B with a different set of numbers. This time you're given the labor force, you're given the unemployed number, and you're given the labor force participation rate. You have to fill in what is the adult population, what is the number employed, and what is the unemployment rate. How are you going to compute those? Well, you're going to do it by the first number, the adult population, should be pretty easy. We know what the labor force is, and we know what the participation rate is. So if we divide the labor force by the participation rate, in other words, put the labor force in your calculator, press the divide button, and put in the participation rate. Punch the equal button, and you're going to get 245,300,000 people, okay, or something very close to that. What about the number of unemployed? Well, again, you've computed the labor, or we know the labor force. You're given that number, and you know the unemployed. So all you do is subtract the unemployed from the labor force, and that will give you the number employed. So you can do that math without me helping you. And to get the unemployment rate, since you know what the unemployed is, you merely divide it by the labor force. Okay, and remember, we've got to convert it to percents, so easily enough done. Okay, and surely you'd have a section C of the problem. And this time they're going to give you the adult population, the labor force, and the unemployment rate, and you have to fill in the other three columns. Okay. Of course, the unemployed should be easy. Take the labor force, multiply it by 1 minus the unemployment rate. Why did we do that? Well, remember, the unemployment rate is the unemployed people. We're trying to figure out the employed people. So we need the reciprocal of the unemployment rate, which would be 1 minus the unemployment rate. Okay. And then to fill in the unemployed, we just take the labor force and multiply it by the unemployment rate that we just computed. And then finally, to get to the labor force participation rate, we take the labor force and divide it by the adult population. Now, do be careful about where your decimal points go. Okay? So that's why I suggest you use a calculator or something. Make sure the decimal points are all in the right place. And then, needless to say, that'll get you through those. Okay? So here we are looking at the unemployment over the last 50 years. Again, very similar to the chart I showed you a little bit ago. Okay, so that's going to be what you're going to be looking at. If you have any questions on that, please contact me at your earliest convenience. I'm here to help you. And remember that this week, make sure you read my announcements. Do that every time you check into class if I have any new announcements posted, because I might just tell you something important. You're going to be doing chapters 11 and 15. This is all explained in those chapters. Definitely do the learning activity. Remember how we're handling the discussions. You're only posting to the first discussion area because of my experiment that I'm doing. Do the Unit 5 assignment. Go ahead and do a post to or not a post, but an entry for your journal and submit that. And the most important thing is if you've got a question, you need to let me know. Okay, so your discussion thread for topic 1 is going to talk about unemployment and minimum wage versus unemployment. Again, there you get into a little bit of supply and demand. What happens when the minimum wage goes up? How many consumers of labor, in other words, businesses, want to hire unskilled workers when the minimum wage goes up? Okay? And the assignment, you're going to see the very assignments we just talked about. Okay? You're going to see computations, and again, if you have the slides laid next to on half of your screen or part of your screen that you can scroll to them, it may help you in figuring out how to do these calculations. That's what they're there for. Okay, so you know how to contact me. That hasn't changed. I'm right here for you. And with that, I want to thank you all very much for attending the seminar. And we will see you next week in the seminar. And we'll definitely see you in the discussion threads. Thank you so much.